This video is on standard function 2, which is properties of function, learning target 2, which is I can graph a proportional relationship on a coordinate plane and interpret its unit rate as the slope. So a couple of things in there is we're going to work with proportional relationships, and we kind of talked about that in the last learning target. That's how we kept getting similar triangles with proportional sides, and then interpret the unit rate as a slope. So a couple things about proportional relationships is that the slope, we're just going to name a slope as many ways as we know. The slope, also I've called it the rate of change. And I know you've heard that in your lower middle school years. Unit rate. And you've also probably heard of it as the constant of proportionality. Shun Al, and then IT. Y goes underneath that. Could squeeze it in there. So in a proportional relationship, the slope, the rate of change, the unit rate, and the constant rate of proportionality all have the same value. And that's what we're going to prove here with this example. So our scenario is a chairlift at snow-capped mountain travels a distance of 30 feet every 4 seconds. So our first question is we're just going to go right with the unit rate, which is the change of the y or change of the x in feet per second. So I want to know what it is, how many feet there it goes in 1 second. So as I look at that, my y, and I see things in graph-like. I'm a visual learner here, so if I think about distance, so I can read that and see that we were talking about feet in second. So I know that second is my independent variable. So it would go on the x-axis down here. So time in seconds. And then the y-axis is distance in feet. The reason I do this, and we're going to graph it here in a little bit, but to me, I know which one goes on top. So I understand which one is my y. So my y is going to have to be my feet. So go back to the storyline. It says a distance of 30 feet. So this is my distance in feet, which we discussed was the change of the y, which is 30 feet. And that's going to go over the change of the x, which in this case is time in seconds. So in this case, it was 30 feet every 4 seconds. Now we set up the ratio correct. We want to get it down to a unit rate. So we're going to divide both 30 divided by, well, we'll just divide it in 2 first, which means it'd be 15 feet in 2 seconds. But a unit rate, remember unit means 1, so we want to get down to 1 second. So we're going to divide by 2 again, and 15 divided by 2 is 7.5 feet in 1 second. So the question, or the answer to this question, is determine the unit rate in feet per second. It'd be 7.5 feet in 1 second. So using that, we're going to now complete a table, that's our verb, to describe this relationship. So a reminder, it's 7.5 feet in 1 second. If we go back up there, we had 15 feet in 2 seconds. And notice these are all proportion or all equivalent fractions. And we started with 30 feet in 4 seconds. So over here, I'm going to look at the x. Remember, this is the x side and this is the y. The x's are changing by 4. Starts at 4, ends at 8. That is a change of positive 4. So my change of the x, which is down here, remember it's change of the y over change of the x, is 4. That means my change of my y has to be 30. So if I start at 30, my change is a positive 30. Then I go to 60. And then at 60, it's going to change to get to 90. So the change is a positive 30 again. So if this changes by 30, go back to my unit rate. Actually, it's just a rate of change up here. 30 is 4 seconds. So we're going to change this by 4 seconds again. So 8, add the 4 seconds, makes 12. then back over here, since this one's filled out, 90 to 120 is a change of 30. Again, that means because my rate of change is going to change by a change of 4. So 12 plus 4 is 16. And then 16 plus 20 is a change of 4 again, which means over here that would be a change of 30. So it's 120 divided by, 120 plus the 30 makes 150. So notice on this table, it's the same proportion over and over, 30 over 4, 30 over 4, 30 over 4, 30 over 4, which we know reduced down to the 7.5 feet in 1 second. So we're going to take those points. Now before that, our verb here is to predict the slope of a line that represents the relationship. How did you determine this value? Well, since I know enough about slope, it's the change of the y over the change of the x, and I just got done doing that in my table. Every time my y changed on this side, it went up by 30, so I know my change is 30, and my x's were increasing by 4 each time, so I know my change down here is 40. Well, 30 over 40 is the same thing of 15 over 2, sounds hopefully repetitive here, and then 15 over 2 is the same as 7.5 over 1. So my slope is 7.5 over 1, or you can name it as 15 over 2 or 30 over 4. All of those are equivalent fractions, so they're the same. So we're going to graph this relationship. So our first one we're going to graph is 4:30. So 4 seconds, 30 feet. 4 seconds, 30 feet. Our next one was 8 seconds, 60 feet. So 8 seconds up to 60 feet. 12 seconds up to 90. So 12 up to 90. And then we had 16. Oops, I forgot already. 16 up to 120. So here's 16 up to 120. And the last one we found was in 20 seconds, we're 150 feet. So here's 20 seconds, 150 feet. So you'll notice a couple of things. Proportion is a constant rate of change, which is what we talked about before. It makes this straight line. Okay, you'll also know that it goes through 0, 0, and that totally makes sense because at 0 seconds, we've gone 0 feet. So that means it's proportional. So constant rate of change goes through 0, 0. I just graphed a proportional relationship. So down here, find the slope of the graph. So we're going to go ahead and use a slope triangle. So we'll go 0, 0. I'm going to go right up to here just for fun. Let's make my right triangle like we've done multiple times. My rise right here is 60. So when I rise 60 feet, so rise over run, or change of the y over change of the x, my rise is 60 feet, and my run, and I can look over to the side here, is 8 seconds, or I can look down here, every box is 1. So 1, 2, 3, 4, 5, 6, 7, and 8 seconds, which I could sit and reduce. Let's just divide them into halves. So that would be 30 feet in 4 seconds, 15 feet in 2 seconds, or as we've known, since we've done this now, this will be the third time, 7.5 feet in 1 second. So the question is my prediction correct? Was I right this whole time? Yes, I keep writing the same numbers, 30 over 4, 15 over 2, and then finally the unit rate of 7.5 feet in 1 second. So the last thing here is we're going to describe what the slope means in terms of the situation by completing the statement. The chair travels 1.5 feet every 1 second, or you could have said the chair travels 15 feet in 2 seconds. Any equivalent amount or proportional amount would work. And last question is, what is true about the unit rate and the slope? The unit rate and the slope have the same value, and in this problem, it was 7.5 over 1. So again, slope and unit rate, they have the same value. And in this problem, that same value, we'll go which was 7.5 over 1.